Gardner and Sons, Patricroft, Manchester, an engine factory that had been running since 1868. The LW diesel, 6 cylinders, naturally aspirated, governed to 1,700 RPM, was in the backbone of British commercial transport for 30 years. Buses, trucks, coaches, nothing on British roads lasted longer or burned less fuel doing it. Rolls-Royce approached Gardner about acquisition in the early 1980s. Gardner declined. A decade later, Euro 1 emission standards arrived. The LW could be modified to meet them. The certification process to prove it cost more than an independent low-volume manufacturer could absorb. The empire ended with a document, not a failure. By the end of this, you'll know exactly why the most durable diesel engine in British commercial history was retired, and why the engine's performance had nothing to do with it. Most people assume an engine disappears because something faster or more powerful replaced it. Nothing replaced the Gardner LW on the measure it was built for. It was retired because the regulatory certification process required to continue selling it legally cost more than a small independent manufacturer could recover at its production volumes. By the end of this, you'll understand the specific economics that built the Gardner empire, and the specific mechanism that ended it without the engine ever being exceeded. Gardner and Sons was founded in Patricroft, Manchester in 1868. The original product was stationary engines, the kind that ran mills and pumping stations and did not move. The company was a precision manufacturer in a city that understood precision manufacturing, and it stayed small by choice. Not because the market was limited, because the tolerance philosophy that defined Gardner's products required a workforce that understood them, and that workforce took years to build and could not be scaled without being diluted. The move into diesel came in the 1920s. The L2 and L3 series established the architectural template that would carry through every Gardner engine that followed. Long stroke, low RPM, bearing surfaces dimensioned well beyond what the power output strictly required, thermal loading kept deliberately conservative. Not the most powerful engine available at a given weight, the engine most likely to run indefinitely at the conditions it would actually see in service. The LW series arrived in 1931, 6 cylinders, 8.4 liters of displacement, governed to 1,700 RPM in standard form, at a time when competing diesels were turning to 2,200 and 2,500 RPM to extract comparable power outputs. The fuel consumption figures the LW returned at governed speed were the commercial case made concrete. At sustained highway cruise, a Gardner-powered vehicle was returning fuel figures that competing engines required forced induction to approach. The number that mattered to a British haulier in the late 1950s was not the figure on the purchase order. It was the figure on the fuel account at the end of the financial year, multiplied across a fleet accumulated over 10 years of operation. A haulage company owner working through that calculation did not need enthusiasm for the Gardner name. 2 sheets on the desk, a Gardner fuel consumption figure at governed speed, and a competitor's figure at the RPM required to match Gardner's power output. Across 500,000 miles of sustained heavy operation, the difference in fuel expenditure was not marginal. It was the kind of number that determined whether a haulage operation returned a profit on a route or did not. The conclusion arrived not as a preference, but as the only reasonable reading of the figures. Gardner-powered vehicles ran slower. They cost less to operate over their full working life by a margin wide enough to make the speed deficit commercially irrelevant to any operator calculating total cost rather than purchase price. That calculation was the foundation the empire was built on, not Gardner's reputation, not institutional loyalty to a Manchester manufacturer. The arithmetic. British commercial transport in the post-war decades rewarded operators who understood total operating cost over a vehicle's full service life, and Gardner's design philosophy had been producing engines optimized for exactly that calculation since 1931. The nationalized bus industry was about to make that foundation institutional in a way no individual haulage company could. British Transport Commission fleet engineers specifying vehicles for routes where a bus might operate for 25 years before replacement were making the same calculation the hauliers had made at larger scale with centralized procurement authority behind them. AEC, Leyland, and Bristol, the manufacturers building the buses the nationalized network ran, offered Gardner engines as standard fitment because the operators specifying the buses were asking for them by name. The Gardner LW was the answer to a question the entire structure of British public transport procurement was asking simultaneously. The empire was built on arithmetic. What nobody had fully accounted for was what happened when the arithmetic changed. The nationalized bus industry did not specify Gardner engines out of sentiment. The British Transport Commission and later the National Bus Company were large bureaucratic organizations with engineering departments that justified procurement decisions in writing against measurable criteria across fleet sizes that made small differences in operating cost significant at scale. The criteria that produced the Gardner specification were the same criteria the hauliers had applied: fuel consumption at operating load, overhaul interval, component life between rebuilds, total cost per mile across a service life measured in decades rather than years. Gardner met those criteria by margins that competing engines at the power outputs the bus routes required could not consistently match. The specification was not loyalty. It was the output of a procurement process that rewarded exactly what Gardner built. The service life the LW delivered in practice was the number that sustained the specification through every procurement review. A Gardner-powered Bristol bus entering service in 1955 was not expected to require engine replacement before the vehicle itself was retired. Overhaul intervals of 500,000 miles were standard. The engine removed, rebuilt to factory dimensions, returned to service. The specific achievement was not the overhaul interval alone. It was what the engine looked like when it arrived for overhaul. Cylinder liners measured with a bore gauge 20 years and 480,000 miles after manufacturer returning figures within the original drawing tolerance. Bearing surfaces showing wear patterns consistent with correct lubrication rather than thermal overload. Main bearing clearances requiring shimming rather than replacement. A National Bus Company engineer running those measurements in the early 1970s was not surprised by the results. This was what Gardner engines did. The surprise would have been finding otherwise. The metallurgy and machining philosophy that produced those results were not accidental. Gardner held tighter tolerances on bearing surfaces and cylinder geometry than the power output of the LW required. The thermal loading the engine ran at governed speed was deliberately conservative. The combustion temperatures and cylinder pressures that produced the fuel economy figures were kept well below what the materials could sustain, because the margin between operating load and material limit was where the service life lived. Competitors extracting higher power outputs from similar displacements were running closer to those limits. Higher power, shorter component life, a different commercial calculation for a different kind of operator. The turbocharging question arrived in the 1960s, and Gardner answered it with the same engineering logic it had applied since 1931. Forced induction on the LW architecture would raise cylinder pressures and thermal loading toward the limits that the conservative operating margins had been specifically designed to avoid. The power output would increase, the service life would shorten. The fuel economy advantage that justified Gardner's commercial position would narrow. Gardner's engineering judgment was that the LW's value was inseparable from the operating conditions that produced it, and that turbocharging would compromise those conditions in exchange for a power figure the bus routes it served did not require. The judgment was coherent. It was also a decision made in a market that was beginning to ask different questions. Through the 1970s, competitors were turbocharging their engines and operators were noticing. Motorway coach operations and longer intercity routes were changing the speed economy calculation that had made Gardner's governed RPM commercially invisible. An operator running coaches at sustained motorway speeds on routes where passenger journey time mattered was making a different calculation than a municipal bus operator running a 25-year urban service life. The power output gap that Gardner's conservative philosophy had accepted as a commercial irrelevance was becoming relevant to a growing share of the market. The national bus company's privatization through the 1980s dissolved the procurement structure that had held the Gardner specification in place. Individual operators replacing centralized fleet engineers, short-term purchase price competing with long-term operating cost in decisions that no longer had a 25-year horizon behind them. Gardner introduced the LWT turbocharged variant in the early 1980s. The power output improvement was real. It arrived after competitors had spent a decade refining turbocharged architectures Gardner had declined to develop. The gap had been building while Gardner held its position. The engine hadn't changed. The institution that understood its value had. Rolls-Royce approached Gardner about acquisition in the early 1980s. Gardner's market position was narrowing. The privatization of the bus industry was dissolving the procurement structure the company had relied on, and the development capital required to close the power output gap with turbocharged competitors was not available from Gardner's own revenues at its production volumes. Rolls-Royce had the engineering budget and commercial relationships that would have given Gardner a path through the regulatory environment already forming around European emission standards. Gardner's management declined. The reasoning was coherent, independence preserved, product philosophy intact, no parent company's priorities imposed on an engineering culture that had held its tolerances and judgments for over a century. The development capital Rolls-Royce would have brought was also foregone. The decision made the outcome probable. Euro 1 emission standards came into effect in 1992. The regulations established specific limits on particulate emissions and nitrogen oxides for new heavy vehicle engines sold in European markets. Gardner's engineers assessed the LW architecture against those limits and concluded that modification was technically possible. Injection timing, combustion chamber geometry, and air management could be developed to meet the standard. The question was not whether the engine could meet Euro 1. The question was what it cost to certify that it did. The certification process required formal engineering development, prototype builds, and dynamometer testing to the regulatory schedule, a fixed cost that did not scale with the production volume of the manufacturer undertaking it. A high-volume manufacturer recovering that cost across tens of thousands of units per year absorbed it invisibly. Gardner's production volumes, measured in hundreds of units per year, made the per-unit certification cost unrecoverable at any price the market would pay. The engine that could have met the standard was never submitted for certification. The last Gardner LW came off the production line in 1993. In the Patricroft facility in 1993, the last engine left the line built to the same tolerances the first LW had been held to in 1931. Not a worn-out design, not a defeated competitor. An engine retired because the document required to continue selling it cost more than the arithmetic supported. The Patricroft facility closed. Tooling and pattern equipment, the specific jigs and gauges that had held Gardner's tolerances for 60 years, were dispersed. Some went to preservation groups, some were scrapped. The drawings survived in archives. What the drawings could not carry was the knowledge that existed in the workforce, the specific feel for a correctly torqued Gardner main bearing, the sound of an LW running with injection timing set to the precise degree the fuel consumption figures required, the visual signs of a cylinder liner approaching the limit of its serviceable life before any measurement confirmed it. That knowledge existed in people. The people retired. Some of what they knew was passed on. Some was not. Gardner-powered buses and trucks continue running in preservation. The groups maintaining them assembled their knowledge from the last Gardner-trained engineers, from archived workshop manuals, and from years of direct work on the engines. A Gardner LW starting from cold produces a sound that identifies itself without introduction, a slow, even diesel note at 7,900 RPM, unhurried in a way no modern engine replicates. People who have heard it know it without being told what it is. There's nothing else running at that speed that sounds like it. The Gardner LW wasn't retired because something exceeded it on the measure it was built for. It was retired because the regulatory process required to continue selling it legally cost more than an independent manufacturer without a parent company's engineering budget could spend. And the engine that could have met the standard never got the chance to prove it. What the Gardner story demonstrates is that engineering longevity and institutional longevity are separate problems. The engine solved the first completely, and vehicles still running on original components 30 years after the last one left the line. The second required development capital and a willingness to accept acquisition. Gardner chose independence. The LW is still running. The company that built it is gone. If this is the kind of story you want more of, subscribe. There are more of them.